one is June 2017, Unit 2. The first question, which of the following is a SI base unit? Like base quantity, length, mass, time, temperature, current, amount of substance, luminance intensity. That is a quantity, and their unit like length is meter, time is second. So ampere is the unit. That is a unit for the current. So that is true. That is a base unit basically. Coulomb is a unit, but that is not the base unit. Joules is not a base unit. Volts is not the base unit. So base unit of the current is ampere. That's why A was the right answer. Then the current in the wire is 25 milliamp. So 25 milliamp means 25 divided by 1000. So 0.025 ampere. And the time is 200. So we need the charge. The current is equals to charge divided by time. So the charge which flow through, that is current into time. So current is 0.025. Multiplied by time, it passed for 200 seconds. So when we multiply these two, we will get how much charge will pass through. That will be 5 coulombs of a charge. So it's a straightforward question. You just have to use a formula I equals Q by T. This is a graph. So which component this graph is? This is a graph for diode, because diode start conducting at a certain voltage. Before that, it does not conduct. So that is a diode. If it was a filament lamp, then what will be the shape of the graph, voltage and current? First, it will be a straight line. And then because heat is produced, so resistance increase, so slope decrease. So filament lamp will be in the red color. If it was a light dependent resistor, initially resistance will be there, constant. But what happened as the temperature increases, its resistance decrease, so slope will increase. So that is blue. Light dependent and thermistor will have the identical, both are semiconductor. So semiconductors have the identical trend. If it was a fixed resistor, then it should be a straight line. So this is actually a characteristic current voltage graph for a diode. So you have to learn these 4 graphs and the explanation as well. Then which of the following is a possible unit of a radiation flux? Radiation flux means how many radiations are coming on unit area every second. So radiation flux is actually power per unit area. And what is power? Power is watt, the unit of a power, and area is meter square. And what is watt? It is joules per second. So I can say joules per second divided by meter square. When I simplify, it will be joules second inverse meter minus 2. So it matches with option D. So radiation flux, or you can also say intensity, is actually power per unit area. How much energy is coming on unit area every second? That is known as the radiation flux. The next question. A source of a sound moves at a constant speed towards the stationary observer. So there's a Doppler effect, because due to relative motion, the frequency which is heard, like example, if this is a source and there's an observer, source is moving towards the observer. So what will happen? Like source is emitting, source moving. So what receive by the observer here, that it will receive a shorter wavelength and higher frequency. And if there was an observer away, observer 2, that will receive a longer wavelength and the shorter frequency. So the frequency of the observed sound is higher because the speed of the observed wave is higher. Speed does not change. It travels with the same speed. The speed of the wave does not change. Only thing what happened, the observed frequency and the observed wavelength changes, but the speed does not change. Higher because the wavefronts are compressed. That is true. As you can see here, when the source is moving towards the observer, the wavefronts, they are very close to each other. So wavefronts appear to be compressed. So B is the right answer. The frequency won't be lower. That is wrong. So it will be higher. So either A can be an answer and B, but why B is an answer? Because the wavefronts will be closer to each other, or we can say they will be compressed. Then in question 6, a motor has a power P. It is used to lift an object of mass m through a height h in time t. Which of the following is used to calculate the efficiency of the motor? So what is the formula? Efficiency is a useful energy divided by total multiplied by 100. So motor has a power P and it is used for time T. So example, if there's a motor, so motor has a power P. So how much energy is taken by the motor? That is power multiplied by time. And this motor is lifting an object. Like using the motor, we are lifting the object. So what is the output energy? That is a GPE, gravitational potential energy, which is mgh. So what is the formula for efficiency? Efficiency is the useful output divided by total input multiplied by 100. So output is mgh, input is power into time and into 100, but there's no option with 100. So potential, basically they will get in decimal here. When we calculate, when we multiply by 100, we'll get in percentage. So it matches with option A as a right answer. So whenever we are lifting an object, the useful energy is a potential energy. And because it is an electrical motor, so input energy is power into time. The next question. Two waves, each of wavelength 2 centimeter, and leave from a source. So this is a source. How much what is the part difference? This wave cover 2.5 plus 2.5, so it cover 5 centimeter. This wave cover 4 plus 4, 8 centimeter. So what is the part difference here? When we subtract 8 minus 5, so 3 centimeter is the part difference. One wavelength is 2 centimeters. So if one wavelength is equivalent to 2 centimeter, so if there is 3 centimeter gap, like the distance gap, how many wavelength difference will be there? X cross multiply. So it means it will be 1.5. So it means 1.5 wavelengths are there. 1.5 wavelength, it means, like example, one wave complete one, another one 1.5. So it means if one completed one wave, another 1.5, so it means the trough will join with the crest, or they will be out of phase. So whenever two waves are out of phase, it means they will have a destructive interference. And what should be the phase difference for a destructive interference? As the two waves are cancelling out the effect of each other, so phase difference should be pi or 180 degrees. If it was a constructive interference, then the phase difference should be 2 pi. So using a part difference, we identify what kind of interference should be there. Because if a part difference is 0.5 lambda, 1.5, 2.5, 3.5, so it means there's a destructive interference. And when there's a destructive interference, the phase difference should be pi, or we can also say 180 degrees. Which of the following quantity may be defined as the magnitude of a greatest distance of a point on a wave from its equilibrium? So the maximum distance from the mean position or equilibrium position, that what we call that as amplitude, because that's the maximum distance from the mean position or equilibrium position, what is known as amplitude. So this is actually a definition of amplitude. Then question 9, the light of varying frequencies incident on a metal electrode, the maximum kinetic energy of electron emitted out. The maximum kinetic energy of electron vary with the frequency. Which of the following is a numerical value of a gradient? Basically, you have the formula E is equals to HF. So if you plot on y-axis, if you have energy, on x-axis, if you have frequency, what will be the gradient? The gradient will be equal to h, where h is a Planck's constant. And what is the value of the Planck's constant? That is 6.63 into 10 to the power minus 34. So A is the right answer. So remember, whenever energy and frequency graph, the slope or the gradient of a graph is equivalent to a Planck's constant. Then the circuit shows as a potential divider. Potential divider circuit, if we need a voltage, which of the following value of potential across 100 ohm? So here, if we need V1 is equals to R1 divided by R1 plus R2 into combined voltage V. And if we need V2, that is resistance of that part divided by sum of the resistance into combined voltage V. Potential divider circuits which divide the voltage. So if we need here voltage across 100 ohm, so V1 equal resistance of that part divided by the sum of the resistance of circuit into combined voltage, that is 12. So when we simplify this, 100 divided by 400, so 0 will cancel, multiplied by 12. And then this 4 and then 3 is there. So that is equals to 3 volts. So for this one, 10, A will be the right answer.